What
Okay.
was the problem
Y cubed plus 2y squared equals 9y plus 18. And then the answer was the solution set is -3, -2, and 3.
Okay, so the thing that I would look at this entire thing as is, first of all, let's get it looking like we don't have things split up all over the place. Let's get it back to the problems that we've seen much more easily solved, like this one here. We'll just move it all over and make it equal to 0, okay?
Oh, okay.
From here, you should be able to recognize that there's a little bit of symmetry, like there's some patterns that pop out. Tell me something that you see.
Mm, oh, you can like rearrange them to have like a descending order, like from the exponents.
So right now they do have a descending order.
Mm-hmm.
So what else do you see? This is where like you really want your eyes to kind of be the one leading. Don't worry about the correct math answers, just something that pops up as being like a ooh, like that's really what we're looking for.
You can group them,
You could group them. Why would you want to group them?
maybe to get it to like a simpler term.
Okay. For me, and that's exactly the correct strategy. For me, I'll let you know that the thing that stood out to me is
Mm-hmm.
that I have 9 and 18.
Mm-hmm.
Like that immediately makes me look at that and be like, there's a 9 and 18 too, right?
Mm-hmm.
And that makes me like, well, what if is there a 9 anywhere else? No. What about just with those two? Probably. Can I do things with just with those two? And that should remind me that we have a technique called factor by grouping.
Mm-hmm.
So we
Okay.
can absolutely pull out a y squared from these ones in front and say that's y plus 2.
Mm-hmm.
Hold on, it's catching up with me. There we go. So we have y plus 2, and then in this one we could look at pulling out that -9, and we would have a y plus 2. And really what we had in disguise up here was nothing more than, again, a rectangle. Like this is a y squared minus 9 times y plus 2 rectangle.
Did you just put it back in? The
Nope, I just
Oh,
factored this
okay.
entire thing out.
Okay, yeah, okay.
And then from here, y squared minus 3, that's an easy thing to factor. That's a difference of squares. That's a y minus 3 by y plus 3 rectangle. And there are all of your solutions right there.
Oh, okay, okay.
You'd
So
be
then,
want to say, when is this thing 0 at 3? This one is at -3, and this one's at -2. There are your answers.
okay, so this is something we can expect, right, on the test.
Absolutely. Yep.
Okay.
This is something that's absolutely within our power. So whenever you see things that are, four terms, whenever you see something that has similar patterns, like just because we're used to working in terms of quadratics doesn't mean that this thing can't be looked at in the same kind of lens. And so that really all we're doing here is another instance of factoring things out to make them look like rectangles.
Oh, okay. And why is it a solution set, not like y equals?
Oh, it is a y equals. Sometimes it asks for it in different things, in different methods, just because it's an easy way to express a lot of answers. Because think
Hmm.
about the way that we would need to write this if we didn't put it as a set. We would need to say we have answers of y equals 3, y equals -3, and
Uh-huh.
y equals -2. Now, sometimes people will write this as saying y can equal 3, -3, and -2. But
Hmm.
this is one way of really kind of showing that, like, if you were writing this out as a sentence or if you were trying to type this to somebody in chat, you want them to really not accidentally think that you meant y equals 3. And -3 and -2 were things that had other meanings. Like we just grouped them together to say these are all in the pile of things that y can be.
Oh, okay. All right.